Bismillahirrahmanirrahim. Good morning, everybody. Today I will introduce to you the first course Preamble Definitions and Generalities of Module Electronics and System Components. I'm Dr. Najat Azzawi, instructor of this module. At first, I divided the course into two main parts, electronics and computing. For the first part, electronics. What is the definition of electronics? Electronics is a branch of applied physics using electricity as a medium for the processing, transmission, and storage of information. In this definition, the notion of information is considered in the broadest sense. It designates any quantity that can evolve in real time, physical or abstract. We pass to the next element, some definitions relating to the electricity or relating to the electronics. Electric voltage is the circulation of the electric field alone on electric circuits. It is denoted U and measured in volts. Electric current is produced by the movement of electrons in the conducting medium. There are two types of electric current, direct current and alternating current. For the direct current, the flow of electrons always flows in the same direction, but on alternating current, the electrons circulate alternating in both directions of the circuit. For the low current refers to the cable networks that carry information. And for the strong current, as opposed to the weak current, strong current is used to transport electrical energy. For the electrical signal is an electrical quantity, electric current or voltage, whose variation over the time transport information from a source to the destination. There are two main types of signals, namely analog signals and digital signals. For the analog signals, they vary continuously over the time. These signals most often reflect variation in physical quantities, for example, temperatures, sound, brightness, effort, etc. And for the digital signals, there are discontinuous signal over the time. It is a succession of 0 and 1 called bits. It is said to be binary. Amplitude. In the highest of the oscillation of a wave, this variable can be length or on intensity or speed, etc. The maximum amplitude is the difference between the horizontal axis 0 and the amplitude of the highest or lowest point, shown in the figure 3. The period it represents the time it takes for the signal to return to its starting point. This is the duration of the signal cycle expressed in the seconds. Frequency is the number of cycles per second expressed in hertz. Look to the figure 3. The frequency equal 1 div period. For the phase is a concept allowing two sinusoidal signals to be compared with each other. On the graph in the figure 4, the two signals are sinusoidal of the same amplitude and the same frequency, but they are out of phase. The phase is represented in the figure 4 by the symbol theta. We pass to the electronic components. An electronic components is or electronic components is an element intended to be assembled with others in order to perform one or more electronic functions. The electronic function of a component is the reason it is used. There are two main families of electronic components, the active components and the passive components. For the first one, active components define the components which make it possible to increase the power of an electrical signal, current and or voltage. This classification includes vacuum tubes, transistors, diodes, integrated circuits, and the light emitting diodes. The first type, vacuum tubes, or in French, tube à vide, generally used as a signal amplifier. The rectifier or amplifier vacuum tube has been replaced in many applications by the transistors. Transistor. It is used in most electronic circuits, as a switch in logic circuits, as a signal amplifier to stabilize a voltage, modulate a signal, as well as many other uses. Diode. It is a dipole which only allows electric current to pass in one direction. The direction of connection of a diode therefore has an importance on the operation of the electronic circuits in which is placed. Current flows from the anode to the cathode. The diode is an oriented component. The third element, integrated circuit, also called an electronic chip, is an electronic component reproducing one or more or less complex electronic functions, often integrating several types or basic electronic components in a volume reduced, making the circuit easy to implement. The last one, on LED light emitting diode. It has the particularity of generating light when a current passes through it. On LED only allows electric current to flow in one direction. It is used in different areas such as lighting, television screens, computer screens, or decoration. We pass to the passive components. The passive components is or define components that do not increase the power of an electrical signal. This classification includes resistors, capacitor, and transformers. For the resistance, reduce the intensity of the current in a circuit. It is measured in ohm, and the greater the number of ohm, the more the current is reduced. Capacitor, the battery or buffer zone, which accumulates current and releases it later. Transformer is a converter used to modify the voltage and current intensity values delivered by an alternative electrical energy source. The voltage and current can be increased or decreased depending on the intended use. We pass to the second part in this course, comparing the computer science or informatique in French term resulting from the construction of information and the automation is the science of automatic information processing. The impact of on society has been decisive. All sectors of the economy, from science to everyday life, in the office, at home, in the car, have undergone significant changes. A computer system is made up of two entities, hardware and software. For the hardware, this is the physical part of the computer and includes the hardware components with which a computer is built. The software, This is the logical part of the computer. It is made up of all the programs that make it possible to operate the hardware. The hardware and the software are absolutely complementary and inseparable in the computer system. A computer system can be very simple. For example, the management of a small business often only requires microcomputers, but it can also become very complex. Large scientific computing laboratories, industries, banks, hospitals, etc. need a large number of powerful computers linked together by network. We pass to history of computing machines. Several classifications have been given regarding the evolution of computing machines. We will give her the evolution of electronic machines that most authors have divided until now into four generations. The first generation use vacuum tubes. This generation is characterized by the use of vacuum tubes or vacuum lamps. These are giant machines built from the first electrical component and wiring. Second generation use transistors. This generation came into existence with the appearance of transistors, which are capable of doing the same work as vacuum tubes, but they are much cheaper, smaller, and more reliable and faster. We pass to the third generation, integrated circuit or use the integrated circuits. This generation is marketed by the use of integrated circuits. Manufacturers have managed to integrate several components to build a signal circuit. This makes it possible to reduce even further the size of computers and to facilitate their maintenance. Now we pass to the fourth generation that use the microprocessors. Who use the microprocessors? This generation is characterized by the use of very large scale integrated circuits called VLSI. The integration can reach more than 100,000 electronic components on the same chip. This generation is characterized by the use of microprocessors, which are VLSI devices. In this table, this table contains the characteristic of generation or generations of computing machines. For the first generation, the first generation is use the vacuum or are use the vacuum tubes, bigger, slower, and less efficient. Use of benched cards and not marketed. For the features of the second generation, use of transistors, faster and smaller than the previous generation. And the fourth generation, use of integrated circuits, flexible and smaller, well suited for the commercial application and known as the mini computers. Fourth generation use the very large scale integrated circuit called VLSI microprocessor. General purpose interactive machines enable rapid application development, easier use for the personal application, can be easily used over a network. And in this column, example for each generation. We pass to the type of computer. At first, what is the computer? The English term computer initially meant electronic digital calculator. Indeed, the first machines were mainly used to carry out sequences of arithmetic or operations. The French term computer is better adapted to today's reality because it moves away from the digital connotation. The computer is now defined as an information processing machine. The meaning of the English term has evolved because it is now equivalent to that of the French term. A computer is normally capable of acquiring and storing information, carrying out processing and restoring stored information. We pass now to the types of computers. The computers can generally be classified by the size, power, and area of application as follow. Supercomputers, embedded computers, and microcomputers. For the first one, very large and very powerful computers, computing speed, which use tens of thousands of microprocessors to carry out certain tasks such as calculations for weather forecasting, for complex calculations to analyze the human genome as well as several other functions. Embedded computers is the components incorporated into a system, car, plane, washing machine, refrigerator, camera, etc. These computers are built to perform a limited number of tasks such as guidance or security. We pass to the third types, microcomputers. These microcomputers divided into five another types represent the most common type of computers on the market. Their power continues the increase. These are different types of microcomputers: desktop computers, portable computers, pocket computers, and the tablet PC and body computers. The first one, desktop computers. Desktop computers are designated to be used on a desk or table. They are generally large and more powerful than other types of personal computers. Laptop. Laptops are portable, lightweight desktop computers with a thin screen. They are often called notebook computers because of their small dimensions. Handheld computers, pocket computers, also called personal digital assistants, PDAs, are battery powered computers that, due to their small size, can be taken almost anywhere. Tablet PC. The tablet PC is a laptop computer like a large cell phone with a touch screen. It usually uses on-screen virtual keyboard, stylus, or digital pen. Typically, this tablet do not need a keyboard. There are two popular categories of tablet PC: slate tablet PC and convertible tablet. The body computers. These computers are small and light because they must be carried on the human body. Body computers come in the form of bracelets, pendants, glasses, and rings. Wearing such devices allows constant interaction with the computer system. Additionally, these devices are multitasking. You can perform other routine tasks at the same time. This computer can be used as a small chip programmed to monitor the movement of animals. And in the end, thank you for your attention.